Hello, good afternoon, everyone. Please allow me to introduce myself. My name is Ratih Devi. Today, I would like to present my study about the addition of biochar, decreased soil respiration in a permanent no-till and cover crop system for organic soybean production. Please allow me to share my screen. Okay. As we know that soil organic matter is very important to agricultural productivity. Even in a small amount, only 2 to 4% of soil organic matter content in the soil. But soil organic matter have a significant role on food production, particularly for maintaining soil to function properly. Soil organic matter also is very sensitive to management practices and current agricultural activities such as tillage, cultivation technique, crop harvest, and residue handling causes a decline in the soil organic matter level in the soil. That indicates by the loss of soil organic carbon. According to Ray and Seller 2001, the mean annual global carbon dioxide flux from soil was estimated around 68 petagram carbon per year, and the soil respiration from the croplands and fields was estimated around 500 gram of carbon per meter square per year. Therefore, the soil organic matter loss caused by the soil respiration must be minimized. Nutrient system enhance residue accumulation in the soil surface that increase the carbon input to the soil. However, the carbon dioxide emission resulting of soil respiration was found higher in the northwest and cover crop system. The addition of biochar into the soil facilitates the storage of carbon in a recalcitrant form that resistant to degradation. And the addition of biochar in the long-term nutmeg and cover crop system has not been reported, and there is an urgent need for this to be discussed, especially under field conditions. Therefore, the objective of our study was aimed to investigate the effect of biochar on different tillage and cover crop management and their interaction on the soil respiration in the form of carbon dioxide emission, as well as the evaluation of the driving factor for soil respiration in undersoil soil. For the material and methods, the experiment was conducted from June 2020 to May 2022 in the Center for International Field Agriculture Research and Education, Ibaraki University, Japan. This tillage and cover crop management has been implemented since 2002 with 6 years of upland rice and the rest with soybean. The biochar addition just applied in 2020. We have three factors of treatment that arrange in the split plot randomized complete block design that consists of tillage, cover crop, and biochar. The tillage consists of no tillage and flow tillage, and then the cover crop consists of fallow management and dry cover crop, and then the biochar consists of no biochar and with biochar management. For the farming management, we usually plant the soybean from July and harvest in November, and then after the soybean harvesting, we plant the cover crop from November and then terminate in the late of May. After that, the field was left fallow for 1 month in June. This is the total precipitation and daily average temperature in the experimental site. The total precipitation was around 1,100 millimeter in 2020 and 1,400 millimeter in 2021. The mean annual temperature was 15 degrees Celsius in 2020 and 2021 respectively. For the gas sampling and analysis, gas was collected in every week at 9 to 11 a.m., which were removed before the chamber installation, and then cylindrical lid was installed on each sampling day. We collect about 100 milliliter of gas was collected using a syringe, and then gas was injected to a 1 liter Tetra Pak at 0, 20, 40, and 60 minutes after chamber installation. Then gas samples were measured using a gas chromatograph within 24 hours, and then carbon dioxide daily flux was calculated based on the ideal gas law in the following formula. For the soil sampling and analysis, we measure the soil bulk density, soil organic carbon, soil temperature at 0 to 5 cm and 5 to 10 cm, and soil volumetric water content at 0 to 15 cm soil depth. For the cover crop, we measure total carbon, total nitrogen, and dry matter biomass. And for the statistical analysis, the data was analyzed using the analysis of variance of or ANOVA, followed by 2 gram post hoc test at P level less than 0.05 for evaluate the effect of different treatment on the second variable. We also use Pearson correlation to analyze the relationship between soil organic carbon and bulk density in the P less than 0.05 level of significance. And for the determination of soil respiration driving factor, we use multiple regression of path analysis using IBM, SPSS, AMOS. And then for the model estimation, we use maximum likelihood method. And for the general model fit, we use chi-square. And we also use the alternatives such as the ratio of chi-square degree of freedom, goodness of fit index, comparative fit index, norm fit index, and root mean square error of approximation. And for the good fit, the model was indicated in the good fit if the chi-square more than 0.05 and then the ratio of semi and degree V less than 3 and then GFI, CFI, and FI close to 1 and then RMSAI less than 0.5. Now we are going to the result and discussion. First is soil carbon dioxide daily flux at various growing season. In this figure, we can see that tillage have significant effect on the soil carbon dioxide daily flux only in the summertime. That indicates by the no tillage have higher carbon dioxide flux compared to multiple flowing. And for the cover crop, affects soil carbon dioxide daily flux in the soybean and cover crop growing season, with dry cover crop have higher carbon dioxide daily flux compared to fallow. But the biochar affected soil carbon dioxide daily flux in almost entire season of observation with biochar could reduce the carbon dioxide daily flux. For the annual and seasonal effect of tillage, cover crop, and biochar on carbon dioxide emission in different years 2020 and 2021. From this figure, we also know that that NT have higher carbon dioxide emission compared to MP, and rye also have higher carbon dioxide emission compared to fallow, but the biochar addition have lower carbon dioxide emission compared to biochar. For the soil temperature, in here we observe the soil temperature at 0 to 5 and 5 to 10 centimeter soil depth. For the tillage treatment was not so strong affect the soil temperature in the soil. Similarly, also for the cover crop effect, the cover crop management also was not so strong influence the soil temperature, but the addition of biochar was strongly influence the soil temperature, particularly in the summertime, with biochar could increase the soil temperature at 0 to 5 and 5 to 10 centimeters depth, and in the winter time, the biochar management could decrease the soil temperature in both depth. For the soil moisture, contrastingly, the tillage have strong effect to the soil volumetric water content. That's indicated by NT have higher soil volumetric water content compared to MP, but the cover crop was not so strong influence the soil volumetric water content. The addition of biochar also strongly influenced the soil volumetric water content in the soil. As we can see in the figure 6, the soil volumetric water content in the with biochar management was higher than soil volumetric water content in the no biochar management in both NP and NT management. This is the carbon content and its accumulation in cover crop at different tillage, cover crop, and biochar management in different years. In 2020 and 2021, the cover crop affect total carbon and its accumulation in the cover crop only affected by the type of the cover crop, with rye have higher total carbon and carbon accumulation compared to fallow cover crop. And this is the soil organic carbon affected by tillage, cover crop, and biochar in different years. This is the box plot of the soil organic carbon in different depth. 0 to 2.5 centimeter, 2.5 to 7.5 centimeter, 7.5 to 15 centimeter, 15 to 30 centimeter, and 0 to 30 centimeter soil depth. From this figure, we can see that NT have higher soil organic carbon content at 0 to 2.5 and 2.5 to 7.5 centimeter soil depth in both years. Follow and follow have lower soil organic carbon content at 2.5 to 7.5 centimeter soil depth compared to rye cover crop, and the wheat biochar addition could increase the soil organic carbon content also at 0 to 2.5 and 2.5 to 7.5 soil depth respectively. And this is the relationship between the soil organic carbon and bulk density affected by tillage cover crop and biochar addition. From this, all of the farming management, we can see that soil organic carbon could decrease the bulk density in the soil. And this is the Q10 value as an exponential function of soil carbon dioxide emission to the soil temperature. At 0 to 5 centimeter soil depth, the Q10 was higher in the NP compared to MP in 0 to 5 centimeter soil depth. At 5 to 10 centimeter soil depth, there was no significant difference of tillage treatment on Q10 value, but the Q10 was affected by the biochar addition, with biochar have higher Q10 value compared to no biochar addition in 2020. But in the 2021, there was no significant difference of tillage cover crop and biochar on the Q10 value unless in the tillage treatment in 2021 that indicates by the NP have higher Q10 value compared to NP. But regardless of the treatment, the Q10 was decreased from 2020 to 2021. And this is the analysis of the carbon dioxide daily flux driving factor using PET analysis. In here, we determine the soil temperature at 0 to 5 centimeter and 5 to 10 centimeter soil depth and soil moisture as an exogenous variable that influence the soil organic carbon and carbon dioxide daily flux. From this figure, we know that soil temperature and soil moisture was correlate positively each other, but soil temperature at 0 to 5 centimeter soil depth negatively affected the soil organic carbon, and the soil organic carbon was positively affected the carbon dioxide daily flux. In the deeper layer, soil temperature at a 5 to 10 centimeter soil depth was directly positively affect carbon dioxide daily flux, but also indirectly affect the carbon dioxide daily flux. But we didn't see the direct effect of soil temperature at 5 to 10 centimeter soil depth to the soil organic carbon. For the soil moisture, soil moisture influence the carbon dioxide daily flux, also mediated by the soil organic carbon indirectly. Therefore, we conclude that the soil temperature compared to soil moisture was the strongest driving factor affecting the carbon dioxide daily flux. And for the model fit, this model was satisfactory fit with the h-square more than 0.05 and probability level of 0.5, and another model fit alternative was acceptable. For the conclusion, the soil respiration was significantly higher in the NT and rye cover crop system only in the summertime when in the soybean growing system respectively. However, biochar addition in the system could reduce the daily, seasonal, and annual soil respiration. Based on the structural equation model of path analysis, the soil temperature was the strongest driving factor affecting the daily carbon dioxide flux in the system. The biochar regulated the soil temperature and protect the soil organic carbon from the decomposition. The biochar amendment could maintain the soil moisture, thus reduce the daily carbon dioxide flux at the summertime. The biochar amendment also increase the soil organic carbon and decrease the soil biodiversity that improves soil porosity, which could enhance micro and macro pores, increase soil moisture, and increase soil water holding capacity, and promote soil aggregation through the formation and stabilization of macro aggregate in the soil. That's all of my presentation. Thank you for your kind attention.